Hello, Augies Worldwide. I'm Dave Kassler, Amateur Radio, call sign KE0OG, here with another episode of Ask Dave. Today we're going to answer a question from a viewer about how to set the compression on the 7300. I'm going to expand that a little. I know that comes as no surprise, but I'm going to expand that a little bit to talk about what compression is and a little bit about the history of compression in amateur radio. And then we'll go into how to set it up on the 7300. And then I have a little tape of listening using my software-defined radio as I talk into the radio. By the way, the radio is connected to a dummy load during all of this. Let's take a look at the charts. Okay, we're going to talk about speech compression and how to set it on an HF radio. The basic problem is that HF radios are limited to 100 watts peak envelope power. That means peak power, not average power. Now, a normal, properly adjusted audio system in a radio will provide a duty cycle while transmitting on a single sideband transceiver of on the order of 20%. That means that your average power is 20 watts, which is a whole lot less than the 100 watts that it's capable of. The ratio of the average to peak is 1 to 5. Now, I didn't put it on the chart here, but if you do compression properly, you can get that duty cycle up to about 40%. So in essence, what that does is doubles your talk power. Now, can we achieve a higher duty cycle, meaning a higher average power? Yes. We have to create an audio input for the transmit circuits that has a higher duty cycle and yet still sounds good. We can do this. Many methods have been tried. Issues abound, of course. Anything other than a fully linear transmit path is going to cause distortion. So if we are going to compress the dynamic range here and pump up the level of the low volume and keep the high level at 100 watts PEP, that means there's going to be a nonlinearity, which means there's going to be distortion. It's just the two go together. It's almost like defining the same thing, two sides of one coin. A little bit about audio characteristics on single sideband. The bandwidth is not the full audio range of the human voice. The human voice ranges from maybe 50 hertz to 8-ish hertz. That'll cover both male and female. Female, you tend to have some of your fundamental carrying tones a little higher in frequency. Now, communications audio is from only 300 hertz to 3000 hertz. Now, this is a holdover from the old Bell telephone toll standards. The local standard was 300 hertz up to 4000 hertz. The toll standards, meaning a long distance call, dropped off 1000 hertz of that so they could push more audio channels into a transmission channel. Now, I just wanted to note in passing here that middle C on the piano is 262 hertz. 262 hertz for middle C. That means middle C is not even in the bandwidth for voice transmission for communications audio. That means everything below it, all the bass in the voice, is cut out of toll quality bandwidth. The reason for this is because the lower frequencies carry the weight. They give the kind of the tenor to the, no, tenor's the wrong, bad word for that. Different meaning of the word tenor, but tenor also means higher frequencies. But it's the basis for the signal. It's what makes the signal sound really good. This is one reason that some hams still love amplitude modulation, because with amplitude modulation you can go down as low as your modulator will go. And that can be down to 50 hertz or 20 hertz or whatever. And so when you listen to an AM signal, it sounds so much fuller and more complete and everything. But this was cut out by Bell Telephone in the early age, because the real information carrying part of the speech tends to be 1500 hertz to 3000 hertz. Now, if you were listening to somebody in, just person to person, it would still be the parts of the speech that change rapidly, meaning the higher frequencies, actually carry more information. Now, speech has a very wide dynamic range. By that I mean the ratio between the loudest sound and the softest sound is tremendous. It's quite loud. It's quite a bit. Now, if you want to use more of the power of your radio, what you're going to have to do is reduce the dynamic range of speech so that the softest sounds aren't so soft anymore. Okay? And there are several ways of doing this. Early attempts at this, first of all, just uses a limiter, a simple limiter. A limiter means that if the waveform goes above a certain point, here I'll show you a picture. If the waveform goes above a point, say here's a sine wave, and say that this right here is your limit, your actual waveform comes up here, over here, down to here, over to here, up to here, and so on. So you're actually physically limiting the size of the parts of the waveform where the speech level is the highest. Now, you can see a problem right here. You see how this, instead of being a nice sine wave, is blunk, another blunk, and you've got, in essence, a square wave. Now, what happens with square waves? Well, square waves, if this is the lowest frequency allowed, 300 hertz, then you're going to get harmonic content on the odd harmonics. If it's 300 hertz, you're going to get additional frequencies at 900, 1500, 2100, 2700. All are within the speech bandwidth. So introducing limiting introduces distortion. You can't get around it, okay? So limiting was first tried. It creates the harmonics within the speech bandpass, and you get intermodulation distortion because it is, after all, a non-linear part of the speech chain. Now, I happened to be at a meeting of the Lockheed Amateur Radio Club, California's version of LARC. I think it's still going strong to this day. I was a member of the club back during the time I was waiting to go into the Air Force because the Vietnam War had just drawn down and they didn't really need very many more people, but they brought me on after 14 months of waiting. Anyway, during that period of time, I was super active on ham radio. And I listened to a presentation at a club meeting to a guy from Collins. And he talked about an interesting idea here. Since doing this limiting creates these harmonics here, why not heterodyne this up to an RF waveform, then do the limiting, then the harmonics will be outside of the passband in RF, and then you can convert that back down to the normal audio frequency. This heterodyne the audio up in frequency, do the limiting, then heterodyne it back down. This is a Collins thing. This moves the harmonics outside the speech passband, but it does not move the intermodulation distortion products out completely. So there's still some. Now, where we are right now is soft limiting or compression. This is a more gentle variation in gain. So we'll have more gain for the lower signals and less gain for the larger signals. It's still nonlinear, okay? We're not providing the same amplification across the board. It is nonlinear, so there will be some distortion. Now, it'll be manageable if you don't overdo it. Now, compression with very sophisticated techniques is extremely common in the broadcast industry because they're the same way. They want every watt of their transmitter power to count. You may have noticed this sometimes listening to content, and then a commercial comes on and it seems louder. That's because the commercials are extremely compressed. Okay? Now, I want to show you how I do my audio for YouTube. My audio processing software is Audacity, and I really like Audacity for two reasons. One, it's very good. Two, it's free. Now, I will not say it's super easy to use. There is a learning curve because there are so many things that you can do here. Now, what you're looking at here is the first 10 minutes of the original voice recording for Ask-Dave 382. This is Ask-Dave 383, showing the full dynamic range from the tiniest little variations in audio to the biggest here. And I have the levels carefully manually set so that it gets the full dynamic range without actually hitting the rails here, okay? So it does not compress or limit on recording. I get it pure as I can get, okay? And you can see, you can even hear what's going on in these very, very low areas right here. So this is, I think, what, a 32-bit, yeah, 32-bit floating point recorder. It's a very nice little recorder. I've had it for years. I'm using a Rode microphone. That's the little lapel mic I have, to a Tascam DR05 recorder. It's an all-digital string, but it is designed for very high-quality audio. Now, here's the first thing I do. See the outliers here? Those are going to cause havoc with speech processing. So I get rid of them. I set up some hard limiting. These are the settings that I happen to use. But the hard limiter takes the big peaks off. Not every little thing. It's like going to this here and just taking a smidgen off the top. Okay? So it takes the big peaks off, and we get this right here. And you can see that the peaks have been chopped off. The normal audio is still there underneath that, but the big peaks, the sibilants and whatnot, are all chopped down a little bit, okay? Then the next thing that I do is compress it, okay? These are my compression settings, okay? So the lower level are amplified more. See, the 48 dB is pretty low, minus 48 dB, but it gets, comes out of here around 30 dB, so minus 30. So it's quite a bit, and then we soften off the peaks, okay? And I also make up to full gain after doing the compressing. And here's what I get. This little thing right here to this. This is the result that I take into video editing. And if there's still a little headroom, I might add a dB of gain. Okay? So we go from this to this. Now you can see where this right here, there's a lot of headroom that's not used, whereas in here, we've taken up most of the headroom so that you can hear this and get still very good fidelity. Now, if I had just limited and then amplified without the compression step, look what happens here. It's all over the place, and I'm not getting the full use of the audio, whereas here I'm getting the full use of the audio. And this is what you're listening to right now, is a waveform that looks just about like this. I have very carefully done many experiments on this to get these levels just the way I like them for regular use. So, setting the speech compressor on your HF radio. You get a dummy load because you're going to be doing a lot of transmitting here. Okay, turn off the compressor. Set the audio gain per the manual. This is just the ordinary audio gain. Then turn the compressor on and set the compressor level per the manual, and we'll do that here. This is from the manual. This is from the full manual, page 4-12, and we're going to go through all the steps here. So we select the single sideband mode, push function, which is down below the screen here, opens the function screen, make sure that the speech compression is off, and then close that. So let's do that. We see here we've got, this is where we start. Down underneath here are your buttons that are labeled menu, function, monitor scope, quick and exit. The menu and function are the workhorses down there. We're going to press function. And when we press function, we get this. We see I have the compressor on, so we turn the compressor off. Okay, and then we come back to here. This is where we were. Now we go into the menu, okay, and we press meter. See this one right here, meter? We press meter, so what we get is all the meters on the screen. We're interested right now in the ALC because we're going to set the audio level control. So to do that, we turn on, we press on the multi button, press on it rather than turn it. Okay, and we set the mic gain here, and the next thing that we do while talking is look at the ALC here. And we see that the ALC is set kind of here where it tells you it is. By the way, that little blue one right there is the most recent little peak. It kind of averages for a little bit and gives you a peak. And it wants this in the 30 to 50% range, okay? Now, then we go back and we're going to turn that compressor on. See the compressor right there. Turn that on. And now we go here and push on the button and go down to compressor and push on that, okay? Now, this right here, we're going to be using this and this. And what we do is talk while that's on. And now we're no longer interested in this because we set that. Because setting and changing the compressor is going to interact with that. We set the compressor so it's our voice is between 10 and 20% in here. Okay, right there. I think I've come up about 18 at the max, 15 on average, right there. The way it came out, I had to go all the way up to 10. That makes me think it's too high. And I'm going to go back to my original settings that I had earlier because they worked really well for me. The original settings were, let's see, the mic gain was 44% and the compressor was 5. Okay, but we're up a little bit here because we're kind of, following the manual to the max, and we get up here to where it's larger, all right? Now, let's just take a look at what happens if we just go back to no compression. Okay, there's no compression on right now. And I talk into the thing, and I just recorded some talking. Again, I'm transmitting into a dummy load, and this gives you an idea of the frequency content of my voice. Okay, I tend to have a lower component that kind of hangs in there, and then the sibilants are up here. I think there are ways in there to change that. I'll have to look to put a little bit more emphasis It's a sort of an audio out tone control. But that's what it looks like. Now if I turn the compressor on and do this, look what you get. Talking into it. It's much more of the headroom is used. Okay? So, I mean, even if you just look at it on the scope here, I'm still 100 watts, 100 watts max. But look how much more gets used. Okay, now what I would like to do is play for you a recording. This is a recording I made first without the compression, and the second one is made with the compression.
Dave transmitting with full power into the dummy load and listening on the software-defined receiver. I am not using any audio compression. Let's see what happens when I do. Hello, this is Dave. Now I am using the compression. Let's see what it looks like let's see what it sounds like on the recording.
Here are some final thoughts. Compression reduces the dynamic range of your signal so that more of it is in the louder part. It boosts the average power out without changing the peak envelope power. You can see why this is of such interest to broadcasters too, because they're limited in the amount of power that they have, but they want their signal to be loud and easy to hear. It's helpful, especially helpful for poor conditions, DX, contests, etc. Now, too much of a good thing is not good. Listen to yourself or have a friend listen and help you set the levels. I listened to myself by recording a little video, and you heard in there where it was rather loud. I think it was too much compression. I'm going to back off a little bit. See, you know, you can go by the manual and do this, but you still have to listen. There's no substitute for the wetware between the ears. Okay, now, beside compression, there are other things that can help. You notice here when I showed you this right here that there was not a lot in the high areas here. Now there was more when I hit the compression, okay? But if I were to boost this up, you see there's a pretty definite difference between low, medium, and high. Now a normal audio equalizer will not even approach these ranges. You'll get like one for here, one for way over, and so on. It's designed for 20 kilohertz audio. Here we're doing just 3 kilohertz audio. We don't get anything in the 4 kilohertz range. Here it is in with the compression, we get a little bit more here. But equalization, meaning emphasizing the middle and higher frequencies over the lower frequencies, with the same caveats that whenever you modify the audio waveform, you are introducing distortion. But if you just do it a little bit, it can help. When I got my Yaesu FT-DX3000, I went through the process on the Heil website for equalizing the headset mic that I had, and it worked very well. And I got tremendously good reports back from people on how well that worked. So there you have it. I should mention that the person who asked the question was Harry Rundall, AC3EK, who is a very frequent visitor on our Thursday live streams. And he said he's been having trouble. He had the compression set high. He got into the DX contest. He wasn't getting people coming back. So he lowered his compression level somewhat and found a lot more people came back to him. That's because he was over compressing, which caused the distortion. And sometimes you'll hear some really distorted signals on the air. They're compressed so hard you can hardly understand them. And that just absolutely defeats the purpose. But adjust that until your friends say, hey, I like that. And then you've got something that you can use. Remember your settings, write them down, and so on. So there you have it. A little bit about compression. We again use the reference station radio as our example, but these steps apply to all of the more modern HF radios, if you happen to have an old tube type transmitter that has compression in the speech amp, be gentle with it and do the same kinds of things, because it's very easy, one, to overmodulate with those tube type amps, and it's very easy to overcompress also. The old ones are almost all just limiters. So there you go. Thank you very much for your time. I hope you enjoyed this video. And if you would like to help support this channel financially, you can do so by going to dcasler.com/support and picking one of the many ways there that helps to increase the channel funds. And subscribe, click like, and until we next meet, 73.